Well, thank you very much. Now, how about a big hand for our speakers for tonight? Good evening, ladies and gentlemen. I'm Jack Daly, Director of the Smithsonian's National Air and Space Museum, and it's a pleasure to welcome you to the 7th Annual John H. Glenn Lecture. As a museum with dual commitments to history and science, we focus all of our activities in three major areas: space exploration, aviation, and planetary studies. Tonight's event is guided by our mission to commemorate, educate, and inspire. Since it was inaugurated in 2004, the John H. Glenn Lecture stands out as one of the most popular events on our annual calendar. As it was last year, the lecture is made possible through the generous support of the Boeing Company. In addition to this series, the Boeing Company has partnered with the Smithsonian on many important projects. Construction of Phase 2 of the Stephen F. Fred Haise Center is on schedule and will be completed this fall. The building's central hangar is named the Boeing Aviation Hangar in recognition of the tremendous support the company has given to this facility. With us tonight is Mr. Timothy Keating, Senior Vice President for Government Operations of the Boeing Company. Mr. Keating, on behalf of the museum, thank you for your support, and please stand to be recognized. Okay. One of the reasons for the success of the John H. Glenn Lecture is its namesake, who is here with us tonight, as he has been for every program since the series began. Although he needs no introduction, I'd like to say a few words to welcome one of the National Air and Space Museum's greatest friends and supporters. Before joining the space program, he served his country in the United States Marine Corps with 59 combat missions in World War II, 63 missions in Korea, and then as a test pilot, setting the transcontinental speed record in the F-8U-1P Crusader, which is a story of its own. One of the original 7 Mercury astronauts, Senator Glenn made his famous orbital flight in Friendship 7 in 1962. 36 years later, John Glenn returned to space on a shuttle mission as the crew's most mature member, with the exalted title of Payload Specialist 2. Between space flights as a member of the U.S. Senate, his commitment to public service continued for more than a quarter of a century. Now, when many of his generation might be enjoying a life of leisure, he is participating in educational initiatives, inspiring future generations of space explorers at the John Glenn Institute for Public Service and Public Policy at Ohio State University. Senator Glenn, thank you for all that you have done for your country and the Smithsonian's National Air and Space Museum. Both you and Annie have supported so many projects and activities here at the museum over the years. At educational events, you've encouraged countless youngsters to excel in math and science and have inspired people of all ages to learn about the history of flight and embrace future of space exploration. Ladies and gentlemen, please welcome Senator John Glenn.
Thank you very much. Thank you, Jack. What he forgot to tell you on that last mission, too, was that the only things on board that ranked lower than I did were the 2 toadfish in one of the experiments back in the bay. Thank you very much for those very kind words. And this year, the museum is recognizing the 40th anniversary of the Apollo 13 mission. And we're honored to welcome the 2 surviving members of his crew, Mission Commander Jim Lovell and Lunar Module Pilot Fred Haise. We're also pleased to welcome Apollo 13 Mission Controller Gene Kranz and Apollo 16 Command Module Pilot Ken Mattingly. Apollo 13 launched on April 11, 1970, and the crew returned safely to Earth on April 17th. But in between those 2 dates, one of the most gripping episodes in space history occurred. Because of an explosion, the lunar landing plan for Apollo 13 was canceled. Instead, the mission's purpose became just to get the 3 astronauts back to Earth safely. Never before or since in the history of NASA have so many individuals worked so brilliantly and quickly to resolve a potential catastrophe. The Apollo 13 story is one of courage, of skill, ingenuity, and cooperation, both on the ground and in space. We'll be hearing a great deal about the mission tonight, but first I'd like to set the stage with a few historical facts. Originally, Apollo 13 was supposed to land in the Frau Morrow area, a more rugged environment than the landings for Apollo 11 and 12. The disaster occurred 55 hours into the flight when a fault in the electrical system of one of the service module's oxygen tanks caused an explosion that resulted in a loss of electrical power and the failure of both oxygen tanks. By the time Jim Lovell commanded the Apollo 12 flight, though, he had completed 2 Gemini missions, as well as flying around the moon aboard Apollo 8. And many of you, I'm sure, were here just a couple of years ago, when it was 2 years ago or 3 years ago, and we had the Apollo 8 crew here to go through that mission with us, and it was absolutely fascinating. It's one of the greatest missions that Jim, of course, and Bill Anders and Frank Borman had was on that Apollo 8 mission. Before being selected as an astronaut in 1962, Captain Lovell had served as a Navy test pilot and program manager for the F-4H Phantom fighter. Until it was surpassed by the Skylab flights, Captain Lovell held the record for time in space with 715 hours and 5 minutes. He retired from the Navy and the space program in 1973. Now, Fred Haise was one of the 19 astronauts selected by NASA in 1966. He served as a backup lunar module pilot for the Apollo 8 and 11 missions, and after Apollo 13 was backup spacecraft commander for Apollo 16. From 1973 to 1976, Fred Haise was technical assistant to the manager of the Space Shuttle Orbiter project. He was commander of one of the 2-person crews who piloted Space Shuttle approach and landing test flights in 1976. He left NASA, resigned from NASA in 1979 to become Vice President of Space Programs at Grumman Aerospace Corporation. The 3rd member of the Apollo flight crew was Jack Swigert. Mr. Swigert left NASA to enter the world of politics in 1977, and he was elected to the House of Representatives, elected to Congress. But before he could be sworn in, he died of bone cancer in 1982. Before serving as lead flight director for the Apollo 13 mission, Gene Kranz worked in NASA's Mercury and Gemini programs as well as on previous Apollo flights. Along with the Apollo 13 crew, Mr. Kranz received the Presidential Medal of Freedom for his contributions to the mission. He later served as NASA's Director of Mission Operations. In his book, Failure is Not an Option, Mission Control from Mercury to Apollo 13 and Beyond, is one that I'm very sure that many of you have read, if not everybody in the room, and describes the philosophy that has proven essential to successful space missions. Now, the 4th member of our panel is Ken Mattingly, who was originally a member of the Apollo 13 crew. Captain Mattingly was removed from the flight 72 hours prior to launch because of exposure to German measles. How would you like to go through all that training and then get knocked out of it? He played an important role from the ground, however. In 1972, Captain Mattingly served as command module pilot for Apollo 16, which brought back samples from the lunar highlands near the crater Descartes. He was also a spacecraft commander on STS-4 and STS-51C. Captain Mattingly left NASA in 1985. So it's my great pleasure to participate once again this year in our annual lecture series. It is an honor to be part of tonight's program. Moderating tonight's discussion will be Margaret Weidekamp, curator in the museum's Division of Space History. Dr. Weidekamp oversees the collections of space memorabilia and space science fiction objects. Among her duties is coordination of this annual lecture series, and obviously we consider that among her most important assignments around here. So please help me to welcome our distinguished panel and moderator to the stage.
Gentlemen, have a seat. Thank you very much, Senator Glenn. Welcome to the museum and welcome to the John H. Glenn Space Lecture Series. We're honored today to be commemorating the 40th anniversary of Apollo 13, which happened just this week, exactly 40 years ago in 1970. And the introductions that Senator Glenn gave to our speakers, I thought really covered their professional accomplishments and who they were when they were going on this mission. But I thought we might also take a moment to remember that these are gentlemen who have known each other for over 40 years as friends and colleagues. And so if I may ask Jim Lovell to start, we'll do a little bit of a daisy chain. Would you say a word about Jack Swigert, and then we can come around with some more informal introductions?
I'd be glad to, because we all miss Jack Swigert. He was a great astronaut, a good friend. He was also, a bachelor. And it's said that he had a girl in every port. I probably believe that. But it was interesting to see him come aboard the spacecraft, because for about a month or a month and a half before the flight, and he was back up to Ken Mattingly, the prime crew took over the simulators, because we wanted to make sure that we were sharp before we left, and the backup crew sort of faded back and helped make the reservations at the hotels for our guests and took care of things like that. And then suddenly, just 4 days before we were to take off, and we suddenly discovered that Manley had the measles, and I was told that Jack Swigert was coming aboard. And, we worked very closely together for months, and I was kind of devastated that, this tightly knit team was going to be changed. But contrary to the movie, those of you who have seen it, Manley was a very dedicated person. The movie sort of indicates that he had to earn his wings every day. That is not true. He helped, design the malfunction procedures for the command module. So if there's one person that had to replace Ken, that was Jack Swigert, and we'll miss him.
Thank you. Gene, would you say a word about Fred Haise?
Fred was, and still is, interestingly enough, if you ever go to any of the flight controller parties, you can always expect Fred to show up there. He was probably the closest of the astronauts, I think, to the lunar module team. We had a rookie team that was building up in preparation for the mission, and Fred was really very close to him, and as a result, they developed a very strong relationship, but mostly there was a mutual exchange of knowledge that I think was very helpful to the members of the team.
Fred Haise, would you say something about T.K. Mattingly?
TK and I were in the same group that came into the program in 1966. It was mentioned the 19. We call ourselves the original 19. And I had the fortune of rooming with TK before our families came down. Ed Mitchell and TK and I shared an apartment. In fact, I shared that apartment with Ken for about 6 weeks. And I found out several things. One is Ken is not a gourmet. He ate a lot of cheese, peanuts. Ken also doesn't sleep much, about 4 hours a night, and that's all Ken needs. So I realized right away that Ken was going to be tough competition in the program ahead. He was very diligent, very intense, didn't mind a lot of long hours. But I think that was key, not to just the job he would have played on our mission, or played in as he did on Apollo 16 and shuttle flights he flew. But I think in a way it probably was more germane that he'd be a part of the team that Gene had, the brain trust that he formed, to make sure that they were honest brokers. I'm sure Ken probably drove Gene nuts at times with questions about why don't you think of this or do that? Because in our business, detail is very important. It's very important to us being successful or still hanging around as old as we are. And so I appreciated, same way Jim, the sadness of having to change out the crew at that 11th hour, because we'd actually worked through the Apollo 11 backup. So we'd already gone through one cycle to now approach this flight on Apollo 13. But I was happy that Ken did have a very successful flight on later with Apollo 16. So he got to look at the moon a lot more than I did.
Let me add one thing about Ken Mattingly that I just discovered this evening, as a matter of fact, because if you've seen the movie again, it appears that there's just the three of us talking, and Ken comes down, and I tell him that he is off the flight, and he goes back and says, well, wait a second, maybe I can talk Chris Kraft or Deke Slayton to keep me on. I don't have the measles. And I say, it's my call. That's not how it happened. I just found out because I asked him. I said, what really happened? How did you find out that you were not on the flight? Because I don't remember. He said that day, Deke came to me and said, look at, you look kind of tired or something like that. Why don't you go out and fly? Relax yourself. So Ken did. Flew the airplane around, got reacquainted to it, got back in his car coming back. I had the radio on. And as he's flying along, the news came up and said that T.K. Mattingly has been replaced by Jack Schleicher. That's how he found out.
Oh, my. TK, would you say a word or so about Jim Lovell, please?
Well, after that, I have a lot of ammunition. Yeah, you folks either know Jim or you will shortly. So I've got a whole bunch of things. The reason I'm here today is to keep these other three honest. But if they get out of line, we have a menu of items that we'll bring up. But for Jim, in a serious vein, Jim, if it wasn't for his patience and willing to take me aboard, never would have had all of these opportunities. And people say, well, what do you remember about Captain Lovell? His name is Shaky, not Captain Lovell. So what do you know about him? What do you remember? Well, there's a lot of people in the program that had very colorful personalities and became known for their pithy sayings and responses. Jim was one of those. And Jim had a phrase that he exhorted quite often. One I've remembered. He said, any improvement will be for the better. We heard that over and over. And the only problem with that is, in those days, we hadn't learned about software upgrades. So, actually, some improvements are not for the better. So, but this is a neat bunch of people. Fredo and I go way back, and our personal objective was to follow a philosophy that said, any day you don't fly is a wasted day of life. And we tried really hard to live up to that slogan.
And if we can close this out, Jim Lovell, would you say a few words about Gene Kranz, please?
Yes, I can say a lot about Gene Kranz, but actually, as a flight director, he was superb. In fact, he became sort of the icon of the of mission control. Chris Kraft came on in and sort of set up the whole thing and told how this whole mission control would take effect and how it should be sort of autocratic, and that we do the right thing, we look at everything fine, and we get these flights to go, we make them as safe as possible, but we have a regulated group of people here. There's regular flow of information. And when Chris then took Gene under his wing, and Gene then absorbed everything that Chris had, and he was a superb member of the team, not just a leader himself, but the way he was able to pass on the information he had to his fellow flight directors and to the people in mission control. And he, after the fire, when we had the disastrous Apollo 1 fire, he, got his group together and said, we have to improve trust among ourselves. We have to get to be more cooperative with the information. We have to do a better job. And that was the motto that Kranz followed all the time. I and Gene occasionally do what we call a dog and pony show, and we go back and forth and talk to various groups. And I'm always amazed because I'm always the second guy to speak and hear how the control center was set up and how things were run.
So where does the story of Apollo 13 really begin?
Well, the Apollo 13 story doesn't start with Apollo 13. It starts with Apollo 14. After a while, after I was back up on Apollo 11, along with my cohorts, and Alan Shepard was assigned to be commander of Apollo 13. Perhaps you don't recall, but Alan was grounded for 8 or 9 years because he had a symptom of Meniere's disease and being unsteady every once in a while. But he had a successful operation, came back up, he was back on flight status again, and Deke Slayton said, look, you've been grounded for so long, you have Apollo 13. And that went on for some time because we were training for 14 until the NASA management, in their wisdom, said, look, Alan has not been trained for so long. Why give him the first flight? Give him some more time to train and make him, give him Apollo 14. And that's when one day Deke pulled me aside and said, Jim, we decided to give Alan Shepard 14. And my heart sank because I thought I was going to be at the end of the line. And they said, would you take 13? And I thought to myself, well, that's not bad. I've got the crew. We were just at backup of 11, so we were pretty well trained. I was on 8, and so that makes it better. And it's 6 months earlier than Apollo 14. And what's the difference between 13 and 14 except the number? And that's how it all began.
Okay. Could you talk a little bit about what the mission goals were and what you were training for?
Hello?
Well, Apollo 13 was going to be the third landing. I guess the primary difference was we were the first ones that were scheduled to go into a relatively highland area versus the plains, which had been the areas that 11 and 12 had landed, primarily to collect the material from Morrow, which was suspected to be the splash, if you will, for those that can see the face in the moon is an area below the left eye that's these hills, and basically that was when the big meteor hit, that was a splash that came out of that large crater that I guess had been formed eons, I'm talking about billions of years ago. And so that was the primary objective. As with all experiments, missions, we had one EVA that was pretty well taken up laying out an experiment package that had a nuclear cast that powered it, which, for all I know, if we could turn them back on, they'd probably still be powered today, the ones we left there. But that was the main mission. Ken and our Jack had a fairly rigorous photo plan, certain targets to shoot, and I think that's where Jack would have fallen a little behind, because Ken was making changes up till the day he got the word he wasn't going to fly. So he was still working with the photo wizards, reconstituting what was going to happen on orbit. But that was basically, and so that was meat and potatoes, I think, of all the flights, except they kept landing in more ambitious places and had a longer lasting limb, starting with 15, so they could stay a lot longer. They had a rover that could, like a little car they could run around on.
By the way, Ken's contribution was tremendous because we had all trained, and we had the simulators to train. But, at 1 o'clock or 2 o'clock in the morning when everybody was trying to get some sleep, there was Mattingly. He was running the simulator just to make sure that everything was correct. And so when I heard that he wasn't going to be on the flight, the first thing I did was to go to to Deke Slayton and the people and say, look we've trained as a team, and teamwork is really the name of this game. I don't want to lose, Ken. And besides that, I said, I can't think of a better place to have the measles than orbiting the moon in a nice, cozy spacecraft. You can imagine how far I got with that argument.
Gene, what did Mission Control anticipate? You must have had some idea of where you thought the tight spots or the tough issues on this mission were going to be.
Actually, the mission control team by this time had pretty well matured. We had grown through, as a team, mostly during the Gemini program and into the early Apollo, Gemini and into the early Apollo. And the thing that was almost miraculous in this thing here, I think to a great extent, the young controllers we had, particularly the systems guys, invented the discipline that we now call today systems engineering. Because the way these guys learned their business, they were sent out to the factory, or they sent to Draper Labs to get to know the people who had designed, developed, and were testing the system, but in particular come back with bundle assembly drawings for how the spacecraft was built and the code for the software formulation within the machine. And they had to translate that into useful materials that they could use on console in real time. So by this time, I think by the time we got to Apollo, we had pretty much developed this set of skills. And now it was a question of testing them in the environment of space and in the operations with the command service module and lunar module. Now we had a new contractor we had to break in. You know, we had worked with the McDonnell and the Mercury and Gemini program, and we were very comfortable with them. But really, the key thing that we did in the early missions was develop the trust that we needed with the guys up in Bethpage and the guys out in the West Coast for North American. So this team was pretty well ready to do the job, and like everything else, we look forward to the time when the mission starts. Training's over, procedures writing's over, mission role discussions are over, and it's ready to go. One last comment on TK is basically it seemed that every meeting I was ever in with him was embarrassing because he always asked the question that I wished I had asked.
Well, it seems that we have, is there anything else that we should be talking about with the crew change, or can I ask about what it's like to launch aboard a Saturn V rocket?
Well, let me, I guess, since I've launched on two of them, I guess I ought to answer that question. When you're out there, many of you have probably gone down in those days and witnessed Saturn V launches. I know I've watched several, and about 3.5 miles away, you see the flame come out as all the smoke and the flame comes out. You don't hear anything until about 3.5 seconds later when the sound waves come over, and then you feel a pressure in your stomach as you feel the pressure waves come out of those engines. To me, inside the spacecraft is a little bit different. And first of all, outside the spacecraft, while you're watching all this, you have a moderator who is giving you a blow-by-blow description of exactly what's happening in the Launch Control Center and what's happening in the spacecraft and what they're doing now. In the spacecraft, you don't hear anything. You sit there and you watch the time come down, and pretty soon they'll say, okay, now we're doing something, and we say, fine. And as the time gets closer and closer to zero, I keep looking at the abort handle to make sure I knew how to grab it. And then suddenly, just before the 10 seconds comes for the final countdown, and then they start to open up the manifold pressures, and you hear the rumbling of all this fuel coming down, really shaking and rumbling, and hits the engines, and all of a sudden the engines ignite, and you get this loud noise and going around and shaking, but there's no pressure waves. There's nothing compared to, seeing what you see outside the spacecraft. We've taken off when the clock starts. And you keep your hand handy, and you're hoping that everything goes good. I mean, everything is working. The engines are going. You didn't have to abort. Unfortunately, we never had to abort one on Apollo and take off. That's my remembrance of our takeoffs.
Let me give you a rookie's opinion of all this. Jim is quiet. Didn't hear anything. His ears were going bad a long time ago. In the real world, anything you heard out there, this rumbling and shaking that goes right into your gut, that goes on inside. And it is a sight to behold. And you think about 7 million pounds is being shaken around you, and it's doing all this stuff, and you really hope it's put together well. and it goes on until this big thing, when it gets up to about 5.5 Gs just prior to shutdown, that giant rocket booster has been pushing hard on a big mass with a lot of thrust. There's about 7.5 million pounds of vacuum thrust. When that thing shuts down, this tin can, which has been compressed, goes whoop and relaxes. Sitting up on the front with the CG behind you says your head goes wonk. If we hadn't been told about, at least if I hadn't been told about that by Apollo 8 and the others, when it got to that point, I got my hand up here. If I hadn't, you would see the instrument panel right here. And then, just as a way to get used to it, they said, okay, you've seen that. Now let me show you something else. And here comes the S2, which is a hydrogen-fueled engine. And hydrogen, it just goes, it doesn't make noise. Even when you're standing outside in the atmosphere, a hydrogen propellant exhaust compared to a hydrocarbon, it is quite unimpressive compared to the two, because it doesn't have all that crackling. And I call it electric propulsion because it starts out and it's a very modest acceleration, and it builds up and it builds up a little bit more until it burns out. And then the S4, which is another hydrogen engine, starts, but there's only one engine on that. And so it really starts slow. And there's no real sensation at this point, except you just see the numbers roll over. When you turn that around, you go into Earth orbit, and then you depart on what we call the Translunar Injection. You light that S4B again, and it's still quiet. It doesn't shake. You kind of look at the numbers and you wonder, this is just like the simulator. And it never gets an awful lot of G's. And you've got a little plot that says your velocity is increasing on this curve. And you watch it and you think, it's never going to go fast enough. Oh, and we've seen this in the simulator 100 times. But in real time, it seems awfully slow as it inches up. And then in the last couple of seconds, it goes whoop, and you're on your way. Now, it may not feel like much to Jim, but let me tell you, if you ever get a chance to do it, take the ride.
You call that an old man's rocket, don't you?
The shuttle is an old man's rocket.
Oh, sorry.
The shuttle is a magnificent machine, and you can sit there and look out these big windows. It's impressive in a different way.
Now, on April 13th, 1970, the Apollo 13 mission changed very dramatically. And I know that's what many of us are really here to hear about. Can you talk to us about what happened?
Let me mention something that happened just before
Please.
the explosion and everything, and it concerns Jack Swikert again, because things were working pretty nicely. The spacecraft was working perfectly. We were happy. We were getting prepared and learning to live in the place, and my two rookies were really, doing a great job. And suddenly, Jack looked at me, and his face was white. And he said, when are we getting back to land back on the Earth? I said, well, we're scheduled to land on the 21st. When do we have to pay our taxes? I said, tax day is the 15th. He said, I got on board this thing. I forgot to mail my taxes in. And we all had a big laugh, of course. We all just chuckled. And he says, I'm serious. They can put me in jail. And then when the word got down to the control center, everybody was just laughing themselves silly until finally someone called up and said, "Listen, I think the president gave you a little bit relief because you're out of the country." Fred, tell us about the accident.
Well, we were doing real good up to at that point, 55 hours, 54 minutes, 53 seconds. We had just had this grand TV show, which actually I saw some of it not too long ago, and I was a little embarrassed. It was definitely not a Hollywood production, sort of a show and tell thing, but it was a thing that NASA wanted us to stage several of these, actually, each flight. And our idea was to pull out things and talk about that we knew the general public had not been exposed to in previous shows and previous flights. We were really ready to end that workday and going to just get things buttoned up to go to sleep and be ready to go into the lunar orbit activities the following day. Mission Control had asked for a cryostar, which is simply throwing some switches that stir up a little fan in the oxygen tank to mix that cryogenic fluid around a little bit. Jack was the only one in the command and service module at the time. Now the movie has me faulting Jack for having done that. Frankly, if I had been in my normal couch position, those switches were in front of me, and I'd have taken a rap for the electric short. But at any rate, that's what happened. Jack threw the switches. There was a very loud bang that we heard sort of echoing through this metal hull. The vehicles are metal, and where I was with my head almost in the tunnel area coming back up, I could hear and see metal popping in the tunnel. And what we saw later with the one panel gone, there'd been quite a bit of thrust imparted on the command and service module sideways that had caused enough bending moment that it actually was rippling the structure in the tunnel area, much like you pop a tin can. But you know, the vehicle's damped out. Wasn't that long after that stopped, and I ended up in the my normal position back in the command modules. There's a lot of confusion initially because the array of warning lights that was on didn't resemble anything we had ever thought would represent a credible failure in anything we'd been exposed to in simulations, because it was in different systems. The vehicles in Apollo were very simple vehicles. There wasn't much integration, only in guidance, navigation, and control through a computer was the only, pretty much the only integrated system. Everything else were standalone systems and normally wouldn't have affected each other. And here we had these lights cross a number of systems that had no relation to each other. So it was a matter then of getting into a step with Mission Control calling for various troubleshooting and actually changing switches to try to isolate the leak. We had one oxygen tank immediately gone, which I knew within the first minute we had lost the landing, because that was the mission rules said we were to return really ASAP. But really, there was a lot of things going on, some that I knew was really bad when I was asked to shut off the reactant valves to fuel cells. In fact, I asked them twice because that's irreversible. Now, shuttle's fuel cells can be restarted, but Apollo's couldn't. And, of course, that's our main electric supply. So anyway, we were just very busy in what I would call troubleshooting, which I don't think Hollywood took much of that script NASA gave them, because it seemed too routine and also a lot of jargon that they figured nobody would understand.
Well, my impression. Oh, go ahead.
No.
Go ahead. Because I think Jack or that Gene should follow. Mm-hmm. My impression was about the same thing, but I looked up at Fred, and I could tell from his expression he had no idea, but he was looking around. I looked at Jack. Jack's eyes were as wide as saucers, because not only did he not know what was going on, but he was saying to himself, "Why am I here?" Because Daly should have been there. Now, I just got on board 4 days before. But that's how we all started the whole thing. And I saw the oxygen escaping, and I knew that that was the loss of the one tank. Actually, it was the loss of oxygen from our second tank. The catastrophe here was the fact that the explosion blew our first tank, which blew off the side of the spacecraft, but it also damaged our second oxygen tank, because had that oxygen tank not been damaged, we'd had enough oxygen, which then fed the fuel cells to provide the electricity, which then allowed us to control the main propulsion engine on the command module to probably get home.
From the ground standpoint, I was just finishing the second shift with my team, and as the television program was over, the majority of my lunar module guys went home because the spacecraft wasn't powered up, and I had a single controller in there cleaning up his procedures. We were going through the pre-sleep checklist, and one of the final items in the pre-sleep checklist is to verify the cryogenic status, and that was what led to the stir. And then I was relatively fortunate because I had another flight director, Glenn Lunny, who was the leader of the block team. He was sitting next to me at the console, reading my notes, preparing for the handover. So as the crew initiated the cryo stir, one last thing. We were sort of set up for this problem because on the same shift we had two electrical problems. We had one case where the high gain antenna switched modes several times with no particular reason for it. And we also had gone through a lot of cycling on the cryo O2 sensor, tank 2 sensor. So as soon as the explosion occurred, we didn't know it was an explosion at that time. The majority of my controller's data was absolute gibberish. And the numbers of calls that came in literally about a 30-second period as each controller was reporting what he thought he was seeing in the console, but truly didn't believe it, coupled with what the crew was calling, was literally chaos. And then the fortunate thing was the training kicked in after about 60 seconds. In my mind, I thought, hey, we had another electrical glitch. We've had these in previous missions, etc. We'll get back on track, solve this problem, etc. But for the next about 1 to 2 minutes, I continued getting calls, and one particular one from my guidance navigation controller says, hey, we've got a lot of jet activity here, and I believe that we're depleting our manifolds. And then he said the crew reported a large bang associated with this, and this was a similar situation I found myself in on Apollo 9. Where we had the shock from a standpoint that undocking had closed several of the valves. And we were moving away in the spacecraft, depleting the manifold. So all of a sudden we were faced with the potential loss of control and damage to the thrusters because we weren't feeding them propellant. We sorted that one out. That was the second mode I went through. We ought to pay a heck of a lot more attention to this because we don't understand what's going on. The real key came when Jim said we're venting something. And as soon as he said that, which was about 11 minutes into this scenario, it was survival mode. And the first thing I called out was WEM lifeboat, and we dug out our lifeboat procedures. We started the power down, going through the power down set of procedures while we're still trying to figure out how to secure the command module. And that was sort of the scenario we went through, but it was somewhat chaotic, but with the realization growing that we had had a major explosion on board the spacecraft with a lot of collateral damage.
Let me give you a blend of that from watching on the side, because this is one of the things I find most compelling about this story. You know, when something unexpected happens to us, especially if it's serious and threatening, what are the first things humans do? They deny it's happening, right? If you've ever been in a car accident or anything else, you know that there is a moment where you really don't, this isn't happening. And this finely tuned team that had gone through so many simulations and every stress you could ever imagine, momentarily turned into a group of people, human beings, grasping at straws to find the solutions. And you say, well, that's not a very good testimony. Let me tell you, it is brilliant. Because in a very short time, in total chaos, we had people convincing ourselves it was instrumentation. I remember Gene saying, "And when was the last time you saw instrumentation venting out the side?" and this guy says, "I tried." Coming from that state of total chaos, this team came back to work, and it was done largely at the beck and call of the flight directors. They went around, and at this point we had both Gene and Glenn doing a shift handover. And so we had two teams really on the loop, which helped an awful lot. But these guys sat down and they started, and they said, find out this question. And they went around the consoles to everyone in there and gave each one a specific question to research and get back to me. Well, this is the way operations go, normally in a regular city. But out of this chaos, in a very short period of time, this magnificent group returned to being that magnificent group. And it is one of the most impressive displays of leadership under pressure that I've ever seen in peacetime.
I might mention what just happened, and along with what Ken said, immediately after the explosion, before we knew exactly, our situation. And it is that feeling that when you're in a serious problem, suddenly you say to yourself, why didn't this happen on Apollo 12? Or wait for Apollo 14? But then all of a sudden you realize that no, it's here, and there. We didn't know what caused the explosion first, but the first thing we thought of was perhaps a meteorite had hit the lunar module, and we were all back in the command module now. And I told Jack, I said, Jack, get the hatch. Close the hatch. Let's secure the lunar module because the command module had heavy shielding around it, and we didn't think that was damaged. And so Jack got the hatch, tried to close the hatch, and could not do it. I pulled him aside. I took the hatch, tried to control it, and I tried to lock the hatch in place. No results. So by that time, it dawned on me that had the meteorite hit the lunar module, we'd have been dead. And consequently, I said, throw the hatch away. Let's try to figure out what else is going wrong. And very fortunately, when it came time on the way home and the separation, we got that hatch closed perfectly.
Follow up a little bit on what Ken said. As I said, Glenn Lundy was sitting next to me at the console preparing for handover. Without any discussion, he went down to what we call the trench, the trajectory side of the house. And in about 20 minutes, he came back to me with 5 maneuver options, because the one thing we had to do very rapidly is make up our mind, which path are we going to take coming home. And it was at that kind of timing, it was also a dramatic demonstration of the team, because throughout all this chaos that was happening in the 2 rows above them, the trench was grinding away, producing answers they knew we would need.
Very quickly, the decision was made to power down the command module Odyssey and to move into the lunar module Aquarius. Could you talk a little bit about the challenges of trying to make that transition and make that decision so quickly?
You want to talk, Fred, about the computers, the guidance system?
Well, the command module, incidentally, it really was a foregone conclusion at a point when that second tank was depleting, and it was a matter of mission control making the call to tell Jim and I to go power up the lunar module. The most critical thing, really, and I forget, Tom Stafford, I think, made that input, because we had this sea of debris around us that it would have been very difficult to shoot stars, to get an alignment of a thing called an IMU, inertial measuring unit, which was going to be critical to have very accurate pointing of the spacecraft to, in essence, carry out one of these maneuvers that Kranz was talking about, Gene was talking about, on how to get back home. And so the most critical thing was to get the LIM to a powered up point where we could manually, based on a transfer of the noun 20s or the angles that were in the command module, which had to go through a conversion because the way the two craft were mated, the axis didn't all align, and that had to be manually input into the computer in the LIM to, in essence, copy those angles for the inertial unit in that vehicle. And Jim did the calculations and, in fact, asked people in Mission Control to check his arithmetic, which they did to make sure the numbers were good before punching them into the computer to get that alignment. We really got to a state then, I felt a little confident because nothing, we got to the point, at least I knew critical system-wise, nothing had been damaged in the LIM. So I knew we had a hangout that was good for life support and communication and even propulsion that we may need for a while. It was a little question mark at that point of how we're going to make it last 4 days when it was a 2-day vehicle. But, you know, we now were in a stabilized point and had time to work other things out.
About the time that the crew was transferring over into the lunar module, Lenny's team had taken over because they were in the process. They had to transfer the nav data from the command module over to the lunar module. And my team went downstairs. By this time, we started to obtain data back from what happened. And until you've torn apart a whole bunch of these analog traces that we got in orange paper, you go into the data room we were in, still trying to figure out what had happened to get a better understanding of the direction we might have to go. And we had people all over the floors, kneeling down on the floors with dividers and Gerber scales and all that kind of stuff. Another person laying out timing marks in this thing here while we were trying to pull this whole thing together. We immediately went through, it was pretty much like it was in the movie, listed in the blackboard all the problems we expect to see, and there are myriads of these things, but it was obvious that the key thing was management of the resources we had on board the spacecraft. And it had a brilliant young engineer from Oklahoma. He should have been a rancher, but he decided to come down to space, which was our good luck, John Aaron. And I gave him the responsibilities as basically the resource manager. Another good guy was Arnie Aldrich, who was the branch chief for the CSM guys, because we knew we would have a very large checklist integration activity. And he was the configuration manager over the stuff that was coming together that we'd ship over the simulators, they'd ship back. So it was not only build the procedures, but manage the configuration as you went by. And then I had a neat guy who was not too good at communicating, but he was very good at thinking, Bill Peters. So we put him in charge of anything that affected survival. He was the first guy that flagged the lithium hydroxide problem we were going to have. So now we got this team moving in many different directions. One final question. We had superb leadership management within that center there. Chris Kraft took over and became the blocking back to keep all of the people off our back while we went and got the job done. He handled all the initial press conferences, and the confidence that he and Deke Slayton showed in the teams during this course was absolutely spectacular.
That superb team that was down there in the control center, the first thing that they really had to think about, because we were on a course that we had changed about 30 hours after we took off, that would get us directly to the moon and have the sun at the proper angle, so that when we went down with the lunar module, we'd have the proper shadows on the rocks and the boulders, so we could maneuver to miss them, because Falmar was a more rugged area than 11 and 12 had gone to. But now this course, had we lost our propulsion system on the main spacecraft, would take us around the moon, and it would take us out of the moon with the moon's gravity, and this long elliptical orbit around the Earth would bring us back down towards the Earth, but would be too far out around the Earth in this orbit to be captured by the Earth's atmosphere for a safe landing. So consequently, had we not done any way of maneuvering, we would be in an orbit that we would never be possible to get back into the Earth. So the first thing they had to figure out was, how do we get this spacecraft back in what we called a free return course that would have us intercept the Earth's atmosphere for a safe landing. And we had to do it with the lunar module because now the command module was completely dead. Oxygen gone, batteries, the fuel cells not working, and the propulsion, of course, was not usable. And that's how they came up with the procedure to use the lunar module and use its landing engine to make the maneuver to get us back on the course. Fredo, you want to talk a little bit about how that was difficult because we had a CG way out one end?
Well, we actually had a lot of trouble. Jim did controlling earlier because that we had to do wanted us to do a PTC, a thermal roll maneuver with the spacecraft that would assure you got sunlight evenly distributed around the vehicle, so one side wouldn't be too hot and one too cold. And by that time, we had powered down and no longer had our 8 balls, the little attitude indicators. And that was a mistake, actually. We should have argued to have at least one of those powered. So Jim was trying to do this with looking at 3 registers on the computer called noun 20s to try to do this maneuver, which didn't work too well, and to get it as precise as the command module could through its computer in an automated form. So we ended up wallowing around quite a bit. Basically, the problem was the center of gravity was well above us, and the command and service module, which was a much heavier vehicle, but also had all its propellant essentially still sitting up there. And so when you maneuvered the vehicle, the only axis on your hand controller, or your stick for airplane people, that worked normally was to twist it for yaw, because that axis went pretty much up through the center line of both vehicles. So if you had to pitch or roll, you really use your translation controller, the thing that you normally use to translate left to right or fore and aft. And by doing that, you could affect pitch and roll. So it's kind of a two-handed operation, and we did it. The maneuvers Jim's talking about, the manual maneuvers, we used 2 crewmen. We had actually practiced a few of those for some lunar abort modes where you ended up losing the SPS engine while trying to get into lunar orbit, and your way of getting around that problem was you would jump into the LEM, do a quick power up, and you'd use the LEM decent engine to exit the moon in some reasonable trajectory that mission control could give you further guidance to get back to an entry. And we didn't do a lot of those, but we had exercised some of those in the simulator. Apollo 9 had actually executed some of those in flight during the Apollo 9 mission. We did have the assist of the FDAIs, the 8 ball, when we did those, which gave us a couple of needles in the center, and it was simply a matter of holding the needles steady, which the 2 of us did through 2 of those maneuvers. We actually did 2 manual maneuvers. They were very short. One was 19 seconds, one was a 21 second engine impulse. And looking at it post-flight, I was happy to see that we did not deviate even 1 degree in any of the 3 axes. And I always say the worst axis was 0.9 degrees, and that was Jim's. Get him every time. But the movie, for those that saw it, had the Earth wavering in the window. Ron Howard had to admit he needed some drama, so that was done in the movie to make it look a lot tougher than it was.
Gentlemen, we have just a few minutes to get you to the moon and home again. So I'm going to speed us up just a little bit. I do want to talk about the lithium hydroxide canisters and the problems you were having with the carbon dioxide buildup in the spacecraft.
Well, of course, this was a problem because we were exhaling carbon dioxide, and there were 3 men in the lunar module the last 4 days, and the lunar module was configured and built for 2 men for 2 days. We had round lithium hydroxide canisters there in the environmental system to remove carbon dioxide. That was the normal way. But they were becoming saturated. And about the time that crew system was already thinking about that because they knew our configuration. And they were trying to figure out down in crew systems how we can prevent the crew from getting poisoned by their own exhalation. Well, in the dead command module, in its environmental system, we had plenty of canisters, lithium hydroxide canister, to remove the carbon dioxide. But they were square, and the command module was dead. And so you could not take a square canister and put it in the round hole of the lunar module environmental system, which it turns out now to be kind of a big engineering goof for having two different canisters in flight. So what crew systems came up with, again using their imagination of what we had to work with, was to take some duct tape, the cover from a manual, a piece of plastic that enclosed a flight suit, or actually some underwear, and an old sock. And using that material, we were able to jury-rig a square canister to work in the lunar module system, and that really was preventing us from really being poisoned on this flight.
This gives you a look at what that final product looked like in place aboard. What was involved in then, once you had gone around the moon and were coming back, with trying to power up the command and service module again?
Yeah, this actually was the thing I was worried about a lot, even though we had to kind of kludge that activation in the LEM to shortcut a lot of things to get it done in time. I knew the LEM quite well. I didn't feel the same way about the command module in particular. That vehicle was never supposed to be powered down in flight. So and we didn't have a book on board. It was normally you follow a checklist, and there was no book that said power up command module for obvious reasons, since it was never intended to be powered down. So it was a missing thing in this in our Plan B. I knew that the people on the ground, Ken for sure, would be involved with trying to develop this procedure, which normally would have taken, if I just sort of had to guess, if you started from scratch to develop a new book like that, the activation procedure, at the time the formulations initially been done with some person designated as the author, and you went through all this trial and error in the simulator, redlining. Then you formally baselined it through a board that officially had to sign off on it and approve it. And then you might make a few more changes as you looked at it in the simulator, each time having to go through the board to be blessed. I figured it would have taken a minimum of 6 weeks to 2 months to get that book issued, if you will, that you'd take it and go fly it. So here they had really less than 4 days by the time probably it got started to make this work. I was very happy because the condition of the vehicle, incidentally, at that time, with the power down we did, it got very cold. The water separator in the LEM wasn't adequate for that temperature and the amount of moisture, and the water built up everywhere. The command and service module looked like somebody had come in with a fire spray hose and had sprayed the vehicle. Water was all over the instrument panels, and I could look where I could look, and it was behind on wire bundles, and I'm sure behind the panels that I could see. And I worried a lot about that thing being okay through this power up, and worse yet, that something would have an error, because that always slows you down, and this had to be done fairly crisply. But it was another one of almost miracles of this flight, in my view. There was not one single error in that procedure, not a one. Normally, you go through something like that, there'll be a warning light come on. That's a normal thing to happen. But if you don't know it's a normal thing to happen, that would stop you. You'd have to say, why that? This thing, everything had been covered. And we ended up, Jack Swigert and I did that activation, and it went through it, and it didn't have one mistake.
I had called down. I was a little worried because when I looked out the lunar module window, the Earth kept getting bigger and bigger and bigger, and I knew we were now on a course that we would intercept the Earth in some manner. And I guess the only time I became a little testy, I said, look, we need just the essential procedures up here. I was worried that they were going to send up other procedures to us to use to help evaluate what caused the accident. And at that time, I kind of wanted the basics.
Yeah, one of the final, Fredo talked about the procedures. There are about 500 items on those checklists for both Command Service Module and the Lunar Module. And the real killer was just about the time we started our shift to start executing these, we got a call from the trajectory guys, say, hate to tell you this flight, we need to perform another maneuver. So we, right off the bat, blew the power profile that we had developed the procedures around. But again, team worked it out.
Well, if I may bring you back to Earth then, can you talk about the landing and what the reactions were aboard the spacecraft as well as in mission control?
I think there were two different emotions. There's emotions in mission control, and there are emotions inside the spacecraft. We were able to power up the command module, got its guidance back. It was working perfectly like a perfectly spacecraft should, and it was meeting all the markers as it was coming in. Of course, we go into this period of blackout where we can't talk to the control center due to the gases coming across in the high temperature of the spacecraft itself and the high speed. But we were looking at it, and it was rolling properly, getting the proper course to come on down, and we were sort of sitting there. At least I was thinking that, hey, this thing is really working out. This is coming along. And of course, the blackout period lasted longer and longer than it was supposed to. They didn't know what the situation was down in the control center. They knew the normal blackout period, and it had passed the blackout period. And finally, we saw then, as we slowed down, the drogues came out, the mains came out, and it was then that Jack said, hello, Joe, I think it was something like that, and everybody was happy. And years later, they said, why did Jack hold off so long after we were on the mains to say, to give a message? And Jack said, well, I kind of thought it might make a movie out of it. So.
From a mission control standpoint, our celebration begins when the crew gets on the carrier deck. And one of the cool things we had with Kraft as a boss, he had a hookup with the Cigar Institute of America. So he managed to somehow or other capture about 700 cigars that were distributed from the West Coast all the way to the East Coast, and that's the beginning of the celebration. The second one is when we open the doors and bring in our backroom troops, and those were the guys who were the real heroes on 13. All we did in the control room was count cadence most of the time, and basically they provided the answers. But the real neat thing was, back when we set up our first space record in Gemini 76 as Americans, we started getting flags from the local undertakers. And what we'd do is we'd get bundles of several hundred of those, and we'd pass them out to each one of the controllers in mission control. And we continued that tradition. The undertakers started getting pretty shaky about providing us flags. But basically, we continued it all the way through the early shuttle program. That's the way we celebrate.
He also wore that vest, that white vest that he wore on all those Apollo flights,
which we are very proud to have upstairs in our Apollo to the Moon Gallery. My last question for the evening would be, what are the lessons of Apollo 13?
Well, I was just going to
Oh, I'm sorry, I've preempted.
I was going to interrupt and ask Gene to comment on, there's a number of things that we've talked about. Things that, like the lithium and the LEM lifeboat, and how do you align a vehicle manually with no guidance system. You know what? The only thing in this mission that had not been practiced in some form, not by this team, not together, the only thing that hadn't been practiced was this powering up from a dead start. And that is not an accident. And I was hoping that Gene would say a few words about the sim supervision and that process, because I've never seen anything like it any other place I've been, and it clearly saved the day.
One of the real key to mission control team's performance is the training process we go through. It's extremely rugged. We assume when the people, when they come to the console, know their business as individual operators. So the training team then takes over and develops scenarios from both that are going to exercise both the crew and the ground team, and we know nothing of these scenarios. And SimSoup is the analog of the flight director. He has a team of controllers that work for him. And the process of this training is not only realistic. The fact is, if you don't solve the problem, you stay there until you solve the problem. And it just forces the team to go to the depths. There's many times then I'd go in there for launch abort trainings for a half day, and 12, 14, 16 hours later, I got a spacecraft stuck up in orbit because they screwed up, and how are we going to get them back home? So this process of training, I use one final word, we practice what they call ruthless honesty. In the debriefing, the flight director leads off the debriefing, and it's sort of like, I'm a Catholic, and it's sort of like going to confession your priest with a loudspeaker in there so everybody that's out in the congregation can hear what the heck you're talking about. But that is the way it has to be. And then SimSoup will say, hey, flight, you forgot that, or this, or that. And they're the real key. If I would talk about, they not only exercise the team, they exercise all the procedures that the team has developed.
Well, if I'm to be ruthlessly honest, we are running short on our time. So I want to give each of you a chance to talk a little bit about what you think the lessons of Apollo 13 are, and then I'll open the questions up to our audience here.
Well, I really think the lessons of Apollo 13 that shows that, that a team that can work a crisis that's almost a certain catastrophe can come out of the catastrophe using what assets they have to make it a successful recovery. I think it shows some of the quality of the people of this country who, in the past and now through the present, have the ability to accomplish things that we normally would not think possible.
I think from my standpoint, it goes back into the culture that we established in mission control. After the Apollo 1 fire, we sat down and wrote out a series of standards that each of us, from very top to very bottom, must meet in order to maintain our excellence as flight controllers and as a team. Talk about discipline, morale, toughness, competence, commitment, teamwork, but there's one that really is very stark, particularly to the new controllers coming into the organization. It says to each controller to always be aware that suddenly and unexpectedly you may find yourselves in a role where your performance has ultimate consequences. Good statement for young kids.
Now, that, to me, if you look at it like it was an accident. There was an accident board convened by Ed Courtright, and if you just say, what did the accident investigation find out? There were some changes, obviously, in the hardware before Apollo 14 flew. A decent battery was added, so if indeed they should lose all their oxygen, they still have a decent battery, which was a major power source. They added a third oxygen tank on the opposite side of the vehicle, those sorts of things. On a minor level, they put some blank paper on board. That was a big problem we had in copying that checklist. We had no blank paper. They put some storage for urine on board because we had this, we got a miscommunication that we couldn't dump urine anymore, so we ended up having to figure out how to store it on board in various odd ways since we had no storage capability provisions, but that was added. But the big thing was that I think lessons learned was that we had this process. We had this process in mission control and training and validation. It was really a validation that we were doing it right, and in a very graphic way.
Well, my take on what lessons did we learn: be careful when you get exposed to measles. It can change your whole life. There's one, I think we've talked about most of the big lessons, but there's one that I think we take for granted, but it's back in the culture. When this thing all started in explosion cable log, and we went through the chaos, and people pulled themselves together. Once they had done that, we weren't coming home, but we had a stable situation. And from, as an observer watching this, what unfolded was we knew some limitations. We knew we had this much propellant. We knew we had this much oxygen, electrical power, and none of those stretched all the way home. And so what do you do? And a philosophy emerged that they practiced perfectly. I didn't appreciate what it was until an investor gave me some guidance a couple of decades later. The philosophy: never get in the way of success. Because we had choices. We debated turning around and coming back immediately, or go around the moon. And listening to all of those discussions, it was never close the door on getting home. We don't yet know how we're going to get there, but make sure you take no step that would jeopardize it. And when they got through, we did have a thread that came home. And I thought, of all of the things, that ranks at the top, because that's what you call sound management and leadership.
Gentlemen, we're very grateful that you came home for the teamwork that was displayed and for your time with us this evening. Thank you. How hard, I'm going to repeat it so that everyone can hear the question. How hard was it not to just turn the heat on when you were so sick and cold on the trip home?
Well, I think Mission Control would have gotten mad at me. No, there was no heater. The way you got the spacecraft to operate in the range you wanted that would be comfortable was you had to turn on a lot of electronics. It was really the balance of the heat from the electronics and their body warmth with the right amount of thermal blankets around the vehicle to make it a good vacuum protected from heat loss that ended up putting you at the right temperature. So we couldn't afford to turn on all that equipment or we wouldn't have got back. So we just had to wear all our spare underwear. I had 3 sets on and grit my teeth a little bit.
Yes. Sir, in the green.
Talked about the astronauts and mission control training, some various scenarios. Was needing to use the lunar module as a lifeboat after the command module became unusable, the most extreme situation you trained for? Was there even anything worse that in retrospect you could say, well, at least that didn't happen?
Was there any scenario more extreme than the lunar lifeboat scenario that you trained for but didn't have to face?
Maybe you ought to answer that for everybody.
Well, that's an interesting question. But from our standpoint, we developed the majority of the lifeboat scenarios back on Apollo 9. I think Fred mentioned that earlier, where the sim soup, go back to the training people. They'd get the LEM spacecraft at the wrong end of a rendezvous. They'd fail the ability for it to maneuver, so we'd have to go into a command and service module rescue. That meant at least 24 hours to accomplish the rescue. So we started developing the power down procedures that eventually turned into the lifeboat procedures. And we had a point of demarcation, so we could start off with those at the time the explosion occurred.
Yes, in the yellow and orange. What does what sound like? What does the master alarm sound like?
What does the master alarm sound
What
like?
does the master alarm sound like?
That was 40 years ago. I think it was a red light that went beep, 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 beep. What did it sound like?
You had to have your headset on to hear it, as I recall. I don't remember hearing it.
Well, there's a red light, I think.
Yeah, it was big. It was a square, about that big square, and you'd punch it. You could punch it and punch it off. But it wasn't an ear-piercing sound. But of course, you're in such a small cavity, it didn't have to be very loud. And the red light caught your attention.
By the way, the movie simulators or the movie props, that was very accurate reproduction of the instrument panel of our command module.
Yes, sir. Blue in the glasses. How can we take the lessons learned from the Apollo program in the late 1960s and early 1970s and use those to reinvigorate the space program of today?
Well, from my standpoint, I'd say that I work with the teams in mission control quite frequently. I've talked often with the program officers in there. I feel those guys are fully competent and do a darn good job along with the contractor teams they've got. So I don't know if there's anything we got to reinvigorate, it's the national will.
Yeah. Well, let me go on to also say that all the astronauts that I've seen, all the people that I've talked to on the street and through my travels after my space days have all said that we need a vigorous program with goals, to set a goal, to do things, and then develop the technology to do that. That was on the schedule until just recently.
Our next question would actually come from the Milestones Gallery.
Yeah, Jim, I wanted to ask real quick on a personal note. What did you say to Alan when you got a chance to thank him for swapping flights?
If everyone didn't hear, what did you get to say, Jim Lovell, to Alan Shepard when you returned about the opportunity to change flights with him?
Well, before I took off and when I found out I got 13 and he got 14, he actually breathed a sigh of relief. But he looked like he was mad that he was bumped to the next flight. When I got back and when I walked in there finally to see Al Shepard, he had that sort of grin on his face. Like, I told you so.
Do we have one more from the Milestones Gallery?
Yeah, my question is, has it ever been determined why the blackout period on Apollo 13 lasted longer than it did on other Apollo missions?
Has it ever been determined why the blackout
I think it did.
coming back
Go ahead.
was longer on 13 than for some other
It's the
missions?
same thing. We were just discussing this. I think that the reason why it was longer is the fact that we were coming shallow on the quarter coming back in than normally we had planned for. We normally come in for a landing coming back from the moon because we are going at super circular speeds, and we have to hit the atmosphere inside a very narrow pie-shaped wedge. And I think that we are continually being pushed off that wedge, and that's why Gene had mentioned another mission or another maneuver we had to do. And the reason was we found out only about 2 or 3 months after the analysis was that the way we cool our electronic systems in the lunar module was to pass water through a heat exchanger where that water would evaporate out into space and then cool other water going through the heat exchanger to cool our systems. Well, that little evaporation, which was insignificant for a normal lunar landing mission, was actually going on for the 4 days coming back when we were using the lunar module. So it was actually acting as a small forcing us off the initial trajectory that we had gotten back onto the free return course to come back. Is that the way you look at it, Gene?
I never heard an answer or an explanation that I believed. There were all kinds of speculation on this thing. Some people, they got these quads around the spacecraft. They say we were in the null area between the antenna patterns, and the other people say that they were in the wrong frequency, and not the crew, the receiving the Orion aircraft that we had out there. But I never heard one I believed. Fredo?
No, I talked to Chuck Dietrich. Chuck was one of the trajectory guys, and Chuck claims we were shallow.
Yeah.
That's his story. I guess we just did Ron Howard a favor, one way or the other.
Well, I think that we are going to have to call in an evening. Thank you very much for the appearance here this evening.
Thank you.
On behalf of the Smithsonian Institution, I want to thank you for sharing your 40th anniversary with us. And we've all seen the movie. We all knew how it was going to come out. But every time we hear this, it's more exciting. And this program has been recorded. It'll be on our website. We invite you to visit there for more information. We have, in accordance with the ethics rules of the government, we have a very modest gift for you. But it's a wonderful book, by the way. It's our latest, called Legacy of Flight by David Romanowski and Melissa Kaiser. We'll mail that to you, so you don't have to pack it to take home. I'd like to acknowledge Senator John Glenn, the namesake for this lecture series. Thank you, Nick. And finally, to once again thank the Boeing Company, because literally these events would not be possible without these sponsorships. So we thank you very much, Tim, for making this possible. There will be no opportunity for autographs or to meet the speakers tonight, so we ask that you exit via the rear doors. And thank you very much for your support of our programs. Look forward to seeing you for another exciting evening here. Thank you very much. Good night.